Okay guys, so this video is going to be on exponential functions. We are going to review a little bit about the two different types of formulas and what those formulas mean and how do I use them. So the two important formulas we have is y equals ab to the x. Remember, whenever we have an exponential function, it means that the exponent is the variable. So the other formula is p1 plus RT, or the same formula with a minus. Okay, so what do those formulas mean? When we are talking about this one, the A represents the start, or the y-intercept. And that's the same thing that the P means. Okay, that's the initial value or the start value or the y-intercept. And then the B represents the multiplier, or we also call that the rate. And that's the same thing as the R. X in this case can be anything. X, or the variable t in the case on the right, represents time specifically. Okay, but it's the same thing. When do I use them? So I use the one on the left when I am talking about or creating equations from a graph or a table. Okay, this is when I'm creating creating equations involving interest or percentages. And we'll see examples of those. Okay, so keywords to look for when we're talking about an exponential equation versus a linear or any other type of equation are words like double or other words that mean multiply, half, other words that mean divide. Okay, we also are thinking about interest, investments. Often when they're talking about bacteria, they're talking about something that's growing quickly. Also growth and decay. Anything that suggests that we're doing something at a quicker rate and it's not constant. Remember, linear things mean they're constant, so exponential should not be constant. Okay, so practice question number 1. To start saving for college, Maria was given $4,000 when she turned 14 years old. Her parents invested it at a 2% interest rate, compounded annually. No deposits or withdrawals were made. Write an equation that can be used to determine how much money Maria had in the account when she turned 18. Okay, so I'm going to cross off my other stuff. Okay, so I need to write an equation. So the equation I'm going to use is the equation that we had on the right, which is the A equals. And we're talking about investing in a savings account, which means I want my money to go up, not down. So I'm going to use the plus. P is our initial cost, or our initial amount. That's the 4,000. R is 2%. But remember, when we're putting these into this formula, it needs to be written as 0.02. I get that by either moving the decimal 2 places to the left or dividing by 100. And then our T if I'm starting at age 14 and I'm ending at age 18, the amount of years that are passing by is 4 years. So I'm just going to go ahead and plug that in my formula. 4,000, 1 plus 0.02, and then to the 4th power. So So I'm going to go ahead and plug that in my calculator. While I'm doing that, you should also be doing that. And I'm going to plug it in exactly how it looks. Okay, and I get A equals 4329.72864. Okay, and since we're talking about money, money only has 2 decimal places, so I'm only going to focus on these 2. All right, and that's going to round up to 4,329.73 cents. Okay. Next question. Some banks charge a fee on a savings account that are left inactive for an extended period of time. The equation is represented here. Y represents the value in the account that was left inactive, and X represents the years. So when they say what is the y-intercept and what does it represent, we're talking about this number. Okay, so the y-intercept is 5,000, and it represents the initial amount of money in the account. Okay, the next one, what is the rate of change in a percentage? So whenever it says it's talking about the rate of change, that's talking about this number here. So 0.98 is our rate, okay? And out of 100, if I multiply by 100 to get the percent, that's 98%. Okay, but it's not asking us of the rate, it's asking us of the rate of change. And whenever it's talking about the rate of change, it's saying out of 100, how much did the percent change? So out of 100%, I'm taking away 98%. So my rate of change is what's left over, and that would be 2%. Okay. All right, for this next one, okay, Company A is offering $10,000 for the first month and will increase that amount by $5,000 each month is important. Company B is $500 for the first month and will double their payment each month. Monthly payments are made at the end of each month. For what month will Company B start to cost more than Company A? So we need to create some sort of table or some sort of information or equation. Okay, the first one represents a linear function, Company A. Okay, so this is going to be at the first month, she's making $10,000, and it's going to increase by $5,000. Oh, I definitely messed that up. Okay, Company B is starting off at, remember this is not the 0 month, this is the first month, at 500, and it's doubling. So that would give me 1,000, 2,000, 4,000, and so on. Okay, so if I wanted to write two equations, this first equation is linear. I'm going to need the y-intercept. Okay, so if I'm finding the y-intercept, I'm subtracting by 5,000, and that would give me 5,000. So the slope is 5,000 x plus the y-intercept, which is also happens to be 5,000. Coincidence. And then, same thing here, this was doing times 2, so I would have to divide by 2 to go backward, and that would give me the y-intercept of 250. So I would get y equals 250, and we are doubling for the x. So what I'm going to do is I'm going to plug these both into y equals. And the reason why I'm doing that is because I want to see at the table which month will company B start to cost more than company A. So right now, the table that we see on my screen, okay, so after I look at my table at month 8, I'm going to see at month 8, if this table continued, at month 8, company A is making $45,000, but company B at month 8 is now making $64,000, which means at month 8, B will cost more. Okay, last but not least, we are looking if it's linear or exponential. If there is a constant rate of change, then I am going to be linear. So if I check this, it's increasing by 60. If I check this, it's increasing by 70. Uh-oh, not constant. So it must be an exponential function. Okay, and I'm not going to do this in the video, but for the next part, you would write the equation in a, bx form, which means you need to figure out what the y-intercept is and what the multiplier is. Okay,